Alright, let's look at some more examples of solving exponential equations. Alright, we said that the first step for solving an exponential equation is to put the equation in exponential form. So we want to identify, let's do this, what's the base, what's the exponent, and have it equal to a single number on the other side. One base, one exponent on that base is equal to a number on the other side. So the exponent, that small value to the upper right of something, is 4x minus 9. That's our exponent. What that exponent applies to is what's directly in front of it. That's the e. Remember when we said when we see e in an equation, e is the base. So we want to get the base and its exponent by itself on one side. The problem we have is negative 6 is not part of the exponent and not part of the base, so we need to move it to the other side of the equation. So we're going to do that by adding 6 to both sides. Why add 6? Well, between the thing we want to get by itself and the thing we want to get rid of, we are subtracting. We will do the opposite of that operation. So now we have e to the 4x minus 9 power is equal to, what is that, 20,072. Okay, so that's step 1. Step 2 is to apply ln to both sides. Alright, so we have e to the 4x minus 9 power is equal to 20,072. We're going to apply ln, put parentheses around everything that's there. We're going to do ln, put parentheses around everything that's there. Alright, we'll use a property of logs. Natural log in e. Ln is log-based e. If the base of the log and the base of the input match, they cancel each other out, and we're left with whatever the exponent was. So we end up with 4x minus 9 is equal to, on this side we still have the natural log, we still have the ln, because the base of the log and the base of the input didn't match on the right hand side. Last step, we want to solve for x. Okay, so right now we have 4x minus 9 is equal to the natural log of 20,072. Alright, we want to get x by itself. So I need to get rid of the 4 and I need to get rid of the negative 9. We always do our adding and subtracting first. I want you to notice that an outside number, so if I add 9 to the outside, it does not apply to the inside of that natural log. So it's plus 9 on the outside of the parentheses. And then the last thing I want to do is to get rid of the 4. We're going to do that by doing the opposite operation. We're going to divide both sides by 4. So our final answer is x is equal to the natural log of 20,072 plus 9, all of that divided by 4. Alright, so that would be our exact solution. What if you wanted to figure out approximately what that number represents? Let's put that into Desmos and see what that is approximately. Okay, so I'm going to go to functions, and we're going to go to, I believe, miscellaneous, and we're going to go to natural log. Okay, so we want 20,072. We're going to go outside of that parentheses, so I'm going to hit the arrow button. I'm going to arrow over, and I believe it was plus 9. I do not know why this keyboard refuses to stay down, but it does. Okay. we're going to divide all of that. So I'm going to put an extra set of parentheses there to say divide all of that. So I just hit that closing parentheses button. Okay, so I'm going to delete that and show you what I did again. Okay, I typed in natural log of 20,072 plus 9. Now I want to divide all of that by 4, not just the 9 by 4, but the whole thing. So I'm going to hit the closing parentheses, and that's going to put everything in parentheses there. And then I'm going to hit divided by, and then I'm going to hit the 4. Alright, so it gives me about 4.73 if I need to round to the nearest 2 decimal places. So about 4.73. And that would be the approximation to the nearest 2 decimal places of that fraction. Alright, so the next 2 examples are pretty similar. Alright. The first step for solving an exponential equation. How do we know it's an exponential equation? Well, the variable x that we're trying to solve for is in the exponent. So that's how we know it's an exponential equation. The first thing I'm going to do is I'm going to rewrite this in exponential form. We want the base and its exponent by itself on one side, number on the other. Alright, so let's see if we can match some things up. The exponent is that little tiny value to the upper right of a number, so that's x minus 3. What is directly in front of that is the base, so the base is 5. And we notice that all we have on the left-hand side of the equal sign is the base and the exponent. Everything lines up with the form that we need. We have the number on the other side, we have our equal sign, so this is already in exponential form. So this step is actually already done for us. Okay. Step 2 says to apply natural log to both sides. So I'm going to give myself a little bit of room in front of each side. And so we're going to apply ln, put parentheses around everything on the left side, ln, put parentheses around everything on the right side. Step 3 says use properties of logs. Okay, we see that on the left-hand side, everything in this parentheses is raised to exactly the same power. So we are allowed to bring that power out to the front. X minus 3, we're going to put that in parentheses because all of that is the power times the natural log of 5. Nothing can happen on the right-hand side because we don't have a power, we don't have any reason or any property of log that we can use on the right-hand side. So that's going to stay natural log of 391. Alright, we want to get x by itself. We have to be careful. The first thing I want to do is undo the multiplication here. So I'm going to divide both sides by the natural log of 5. And this is my solving for x last step here. So I get x minus 3, the natural log of 5's cancel out, equals natural log of 391 now divided by the natural log of 5. The last thing I want to do is to get rid of that negative 3. Remember, my whole goal here is to get this x by itself. That's what we mean when we say solve for x. So now I'm going to add 3 to both sides of the equation. And we get x is equal to, those 3's cancel out, the natural log of 391 divided by the natural log of 5 plus 3. And this would be our exact value. Let's see if we can figure out the approximate. We want natural log of 391 divided by the natural log of 5 plus 3. Okay, so I'm going to go to Desmos. Functions. I want natural log we said 391. Sorry, my keyboard keeps popping up. It's driving me crazy too. So natural log of 391, remember we're going to come out of that parentheses, so I'm going to hit the arrow, make sure my cursor up here is outside of the parentheses, and we want to divide that by, we said natural log of 5, so functions. Okay, now I want to come outside of this entire fraction, so I'm going to arrow over. That takes me out of the log, but I'm still in the bottom of the fraction, so I'm going to arrow over again until I'm outside the fraction completely. Alright, so natural log of 391 divided by natural log of 5, let's just go back really quick, plus 3 on the outside of the fraction beside it. So I'm going to say plus, and then I'm going to hit 3, and there's my approximation. So 6.7, if I'm rounding to the nearest 2 decimal places, that would be 6.71. Okay, in my math lab, you might be asked to find the exact value and also the approximation. So you want to make sure that you can play around with Desmos enough to figure out how to put that into that graphing calculator. Alright, our last example is very similar to that one. Alright, so these two are very similar. The first thing I want to do when I'm solving an exponential equation is to rewrite in exponential form. Alright, that means that we want the base to the exponent is equal to some number. So when I look at this, I see this little exponent, 2x minus 5. That's that little tiny value to the upper right of some number. 2x minus 5 is the exponent. Okay. The base is what's directly in front of it, so the base is 7. So we can see pretty quickly that the left-hand side is already in exponential form. Get the base to the exponent, there's nothing else beside it. The number on the other side is 482. So we are already in exponential form, which is nice. That's done. Step 2 is to apply ln to both sides. Give myself a little room in front of each side. Now I'm going to apply natural log. So ln, put parentheses around everything on the left, ln on the right side of the equal sign, and then parentheses around everything that comes after it. Okay, we're going to use properties of logs to simplify. Inside of the log on the left-hand side, we have everything inside raised to exactly the same exponent. So this is the power rule. The power rule says that if everything inside of the log is raised to the same power, then I'm allowed to multiply that power out times the front of the log. That's 2x minus 5. I'm going to put that in parentheses so that I know all of that came to the front of the log, times the natural log of 7 equals the natural log of 482. Step 4, we want to solve for x. So I want to get x by itself. Here we go. So we have a few things we want to get rid of. We want to get rid of the 2. We want to get rid of the negative 5. We also want to get rid of the natural log of 7. Let's do that multiplication part first. Let's divide both sides by the natural log of 7. That gets rid of the complicated part pretty quickly, which is nice. So I end up with 2x minus 5. Don't really need the parentheses anymore because I've gotten rid of the multiplication. These cancel, and I'm left with natural log of 482 divided by the natural log of 7. Okay, we're still solving for x here. I want to get rid of the minus 5 and the 2. So we'll do the adding and subtracting part first. So I'll add 5 to both sides. Those cancel out. Now the last step here is going to be a little interesting, a little bit different. I could go ahead and divide both sides by 2, but then I create this big, huge, ugly fraction, which is fine, but typically we don't like to write this big, huge, ugly fraction in Desmos. We don't like typing that in. So we're going to do something a little different. Okay, so if this is the first time you've seen it, well, here you go. We're going to multiply by the reciprocal. Okay, so here's a new strategy. Instead of dividing both sides by 2 and creating this huge ugly fraction on the right hand side, we're going to do something a little different. I'm going to multiply by the reciprocal of 2. Okay, why is that? Why would I choose to do that? Well, think about this as 2 over 1. If I multiply by the reciprocal of 2, the 2's cancel out, and I'm left with 1 times 1 over 1, which is just 1 times x, which is just plain old x. So to get x by itself, one way to do that is to multiply by the reciprocal of the number that's in front of x. And I just get plain old x. Now, we all know the rule for equations. If I multiply by 1/2 on the left side, then I have to do it to the right side as well. And not just to a part of the right side, but everything on the right hand side. So I'm going to multiply 1/2 times that fraction. So I get natural log of 482. Okay. 1 times the natural log of 482 is the natural log of 482. At the bottom, we do bottom times the bottom. 2 times the natural log of 7 is exactly the same thing. 2 times the natural log of 7. Outside numbers do not go inside of the log. Inside numbers don't come out of the log. So that's as good as that gets. Now I have to do the same thing to the plus 5. We're going to multiply that by 1/2. It helps sometimes to think about everything as fractions when you're multiplying by a fraction. So if something doesn't look like a fraction, we can make it look like a fraction by putting it over 1. Top times the top, so 1 times 5, we get 5. 2 times 1, I get 2. So I'm going to say my final exact answer is going to be that. Looks a little bit nicer than a big huge fraction divided by another big huge fraction, so it just looks a little bit nicer. Alright, let's work on putting this into Desmos. Okay, so we have the natural log of 400. And 82. Divided by the natural log, what do I have here? Was it 2 times natural log of 7? Just going to put my cursor in front of that natural log and put a 2 there. I believe that was that 5 over 2? So 5 divided by 2. Alright, so I get about 4.0, let's say about 4.09 if I round up to the nearest 2 decimal places. So 4.09 looks like that is our approximation. So we might have learned a new strategy here to multiply by the reciprocal. Keeps things looking a little bit nicer and a little bit easier to type into Desmos.